These are the notes continuing on the section 8.2 on-level notes for properties of parallelograms. These are the examples on the back page. So let's take a look at number 1. It says solve for x. Each of the following figures is a parallelogram. Notice that we have two angles. The angles are on a vertical line. They are side by side. I have consecutive angles. And what do we know about them? They are supplementary or add up to 180 degrees. That means I have to take the measure of angle Q and the measure of angle P and set it equal to 180 degrees. So I've got 2x plus 74 plus 2x plus 106, and that equals 180 degrees. I need to combine like terms. I've got a 2x and a 2x. That is 4x, and I have 74 plus 106 plus 180 equals 180 degrees. I've got to subtract 180 from each side, and I have 4x equals 0. That means if I divide by 4, I still have x equals 0. Well, gosh, that's not a normal answer, but let's plug it in and see if it makes sense. If I have 2 times 0 plus 74, I have 2 times 0, which is 0, which just gives me 74. Let's find the measure of angle P. 2 times 0 plus 106. If 2 times 0 is 0, I simply have 106. If I add 106 plus 74, that gives me 180 degrees, and x is 0 because that makes those consecutive angles that are supplementary. Let's look at our second example. We're also dealing with angles here, but this time they're on the diagonal. That means they are opposite angles. What do we know about opposite angles? Our theorem says they are congruent. That tells me how to set up my equation. That means I'm going to take angle x, 15x plus 5, and set it equal to angle V at 16x plus 2. Now we're going to do a little algebra. I'm going to subtract 15x from both sides. I'm left with 5 equals x plus 2. Let me subtract 2 from both sides, and I get x equals 3. Now, let's do a check and substitute them back in. 15 times 3 plus 5. 15 times 3 is 45 plus 5 is 50. Let's look at here. 16 times 3 plus 2. 16 times 3 is 48 plus 2 is 50. They are in fact congruent. All right, let's look at example 3. Here we're looking at opposite sides. We know that one of the properties of my parallelograms says that opposite sides are congruent. It really helps that we're writing these properties down to get them into our mind so that we can work our problems with ease later on. Here, we've got DE is opposite CF. Therefore, I'm going to set them equal to each other. 2x plus 11 is equal to 4x minus 1. Once again, it's time to do a little algebra. We're going to subtract 2x from each side, and I get 11 equals 2x minus 1. We'll add 1 to both sides, and we get 12 equals 2x. And we're going to have to divide that 2 away, and we're going to get x equals 6. Let's substitute that value back in to verify. We get 2 times 6 plus 11. 12 plus 11 is 23. And here, 4 times 6 minus 1. 4 times 6 is 24, minus 1 is 23. Check. We've got that one down. Great. So let's look at number 4. It's giving us BR and RD. Well, here I'm going to locate BR and going to write that in so that I know what I have. And RD is 1 plus 6x. Well, one of our properties states that if it is a quadrilateral, is a parallelogram, then its diagonals bisect each other. Meaning that dr is equal to br. 1 plus 6x is equal to 5x plus 4. I'm going to subtract 5x from both sides, and 1 is equal to, got a little ahead of myself, 1 plus x is equal to 4. Now I'll subtract 1 from each side, and I'll get x is equal to 3. Once again, we're going to do a check, just a quick one. 1 plus 6 times 3. 6 times 3 is 18 plus 1 for a total of 19. And here we have 5 times 3 plus 4. 5 times 3 is 15 plus 4 is also 19. Check. Another job well done. All right. Now for this last one, I'd like for you to pause this video right now. You work the problem on your own and come back and check your answer with me. Okay, let's see what we have. WB is x plus 5, and WY is this entire diagonal. Once again, we know that diagonals bisect each other. And so here we have the whole and one of the parts. This sets up an interesting situation because it takes 2 pieces, because these 2 would be considered congruent to equal this. So I have to say 2 times x plus 5 is equal to the entire diagonal. The 2 represents the number that would go right here. Now I have to distribute that 2 into my parentheses. 2x plus 10 equals 3x plus 2. And now we've got a little bit of algebra to do. We're going to subtract 2x from both sides. We're left with 10 equals x plus 2. We're going to subtract 2 from each side, and we get x is equal to 8. Let's see if this works. We're going to substitute in 8 here. 3 times 8 plus 2. 3 times 8 is 24, plus 2 is 26. So here, I have to add 8 plus 5, that's 13. And that means that this piece would be 13, and 13 plus 13 is 26. Check.